Next, we're going to learn about regular expressions and shell globbing. Regular expressions are a language used to parse strings to pull out specific content. System administrators and developers alike use regular expressions in their everyday lives. First, some definitions. A string literal is any character that we use in a search or a matching expression. For example, to find the NUX in the word Linux, the NUX is a literal string. It is literally the string we wish to find. A meta character is one or more special characters that has a unique meaning and is not used as a literal in the search expression. For instance, consider the caret character, which is the Shift 6 key on your keyboard. This is a meta character that matches the very beginning of the line. Next, the search expression, also known as the regular expression. This is the expression that we will be using to search in our target, or in other words, it's a pattern that we use to find what we want to find. Consider, for example, the string bwhaley@gmail.com, my email address. The search expression caret bwhaley@ followed by $* matches any line beginning with bwhaley@ followed by any character at all. So if we wanted to find bwhaley@gmail.com in a text file, and where bwhaley starts the line, this is the search expression you could use. An escape sequence, or just an escape character, indicates that we wish to treat a meta character as a literal. So this is a little confusing, bear with me. Consider the case of the word persons, where the S is in parentheses, meaning it would be person or persons, plural. If we wanted to find just the S in the target string, we need to escape the parentheses since they're also regular expression meta characters. The search expression becomes then \, open parenthesis, S \, close parenthesis. And in this case, the \/ character is the escape sequence. Let's look at an example on the command line. I'm already logged in directly to my Vagrant Linux box. I can use the egrep command to search within the etc passwd file, which is the same file we used before when we were learning about how to filter commands on the command line. In this example, we're using egrep, the extended general regular expression parser. Actually, grep comes with many definitions. That's the one I chose here. In this case, we're matching any of the characters W, Y, or Z as they appear in the etc passwd file. Note that all of these lines contain at least one of those characters, but it doesn't mean that those characters are all in a row. It just means that the line has to contain the character somewhere. Similarly, we can use some shortcuts like capital A through Z, which matches any uppercase character. In this example, the output shows every line contains at least one uppercase character. We can show an example where we need to match a certain number of occurrences of a character. Consider this example. We're using egrep to find X and then a colon, which as we can recall is a field separator, followed by 0 through 9 at least 3 times. We can see that in each of these lines of output, there are at least 3 digits in a row, and that these are all of the lines in the etc passwd file that match 3-digit user IDs. We can match the beginning or end of the line with the caret and $. For instance, if I use egrep *r and search in the etc passwd file, I find all the lines that begin with R. Similarly, I can match lines that end with H by using $. In this case, the results are all where the shell is bash for that given user. We can use the pipe character to separate words. For instance, we can search for either the word bash or the word false with a $, indicating it's at the end of the line. Note that all of the output we matched either ends with bash or with false, which is just a false shell. It doesn't do anything. We can combine these techniques to search for very specific things. For instance, if we wanted to search for the string starting with an R, continuing with any character, and ending with bash, we can use this syntax. *r .* bash $. The shell also supports a limited set of regular expressions, or regular expression-like language, known as shell globbing. The shell itself doesn't support a really large number of regular expressions, but you can do some subset of the command, such as ls*, which lists all of the files, and in this case a directory, newdir, in this directory. We can also move things around. For instance, if I wanted to move n*, which should match the newdir in this directory, to /temp, now I've moved the newdir to /temp. That's a brief introduction to shell globbing and regular expressions. If you familiarize yourself with regular expressions, you'll find it to be very convenient on the command line.